Okay, so now that I have my language processing code working and I'm generating a list of the most common words, both the ones that exist only in OCT, the ones that exist everywhere, and the ones that exist only outside of OCT, that's already pretty good. I can use these resulting word data sets to do a lot of different kinds of analysis. I can search for those words in the rest of the comments of the city. I can do a lot of stuff. But the next thing I want to do is actually convert that text data to some kind of features or data about my comments. And I want to do that so that I could use it to apply actual machine learning framework to make some kind of prediction about comments based on the kinds of words that exist in the comments. Okay, so what I'm doing here is taking all the comments in OCT and I'm just generating a list of the most common words that are just in OCT. And what I want to do now is develop some kind of process that would be able to take any comment, so any one of these comments from anywhere in the city, and then make a prediction based on what words are in here, whether this comment came from a place like OCT or didn't. Okay? So as you remember in this script, along the way, we were storing not just this bag of words, but also we were storing the text itself. Right? So we had two lists, a target list and a not target list. And here we're just storing the strings themselves, so literally these pieces of text. What I'm going to do now is start making a script that creates a training data set for a classification type of supervised machine learning algorithm. And as the training set, it's going to have a bunch of strings of comments. And because I've generated two lists, I'm going to know whether it came from OCT or not. So that's going to be my target value. It's a category, whether it's 1 for in OCT or -1 for outside of OCT. And then the feature data, so this is the data that describes each comment. To generate that, I'm going to actually count the number of times that these keywords that I'm generating here occur in each string. Okay, and that's going to form the kind of training descriptive feature data that the machine learning algorithm is going to use to start to classify these comments. And then once I have that framework and I can, with some degree of accuracy, predict whether each comment came from OCT or not, I can apply that framework or that model to every comment in the city and basically specify whether each comment came from a place like OCT or not, and use that to start to categorize the actual places as like OCT or not like OCT. Okay, so I'm going to start developing that in a new script, but before I do that, I'm just going to export a few of these data structures from this piece of code with the pickle library. It's because this library might take a while to compute, especially if we start using bigger subsets. Okay, so something more than 1%. The bigger subset you use here, the more accurate your mask will be in terms of figuring out if something is unique to OCT. Okay, what I'm going to do is export a few files that I'm going to have to use later. So first I'm going to import the pickle library, and then I'm going to dump out as outside files a few of these data sets that we'll use in later scripts. So first I'm going to dump out my list of words. So here I have in, both, and out lists. I'm going to dump each one to separate pickle files in my system. Okay, so this is exactly what we've always done for exporting files. I'm just going to copy and paste that and export all three of my word lists. Okay, and we're going to use these word lists basically to develop our machine learning training set in the next script. Okay, and the next thing I want to do is also dump out my two sets of training words. So this is this target text list and not target text list. And when you're doing this, it helps to have these match, so it's always consistent. You don't have to, the name of the file doesn't have to match the name of your data, but it helps just to keep everything consistent. Okay, so now I have my pickle files being generated at the end of my code. I'm still generating these text files just so I can see the words and troubleshoot that, but I'm actually going to use these files in later scripts. Okay, so once I have that, I'm just going to increase this to something a little bit bigger just to generate a little bit more accurate data set. How much data you can take here, it really depends on the capabilities of your system. Okay, because as it's running through, when it analyzes this text, it actually stores it in your random access memory and has to store it there until the end of the script. Okay, so it really depends on how much RAM you have in your system. To show you that, I'm just going to start my task manager and go over to performance. This is Windows specific, but there's similar tools for Unix systems as well. So here performance shows my physical memory usage. This is my RAM. I have a maximum of 8 gigs. Right now I'm actually using already 62%. Okay, so if you're already using a lot of RAM, basically you want to clear as much of this out as possible before running your script, because it's going to give the script more resources to work with. Okay, and at some point, if you try to use more RAM than your system has available, it's going to give you a memory error and the whole script will just exit. All right, so a few ways to clear some random access memory. First, you want to make sure that any script that's run before isn't reserving memory on your system. And a quick way to have a clean slate, you don't have to close Canopy, although that will do the trick as well. But if you want to keep this open, you can just go to restart kernel and restart, and that'll close any current session of the actual Python kernel and free up some memory. And then another thing you can do is actually go into your processes tab. You can sort by memory. This is the amount of memory that each process is using, and start to close some processes that are not super important but are hogging some of your random access memory. So in this case, Chrome actually takes up a lot of RAM on your system. You can see here 180 megs. And I know that's just a browser, so I can safely end it. You don't want to end any process that you don't know what it is, because it can actually disrupt your system. Here, box sync, I can close. Explorer you want to keep. Python, this is actually a Canopy running, so you want to keep that. I can close a few of these, like Sublime Text. Okay. Now if I go back to my performance, you see that just closing those few processes actually cleared a lot of my RAM. So now I'm going to run this script to basically generate my final list of words and strings. And as I run this, I'll show you what happens to my RAM. So it's running now, it's processing through the whole zip file full of comments. And as it's processing, it's analyzing some of those strings. And as it's doing that, it's actually storing them in your RAM. And you can see how the RAM usage is steadily going up. If you go to process, you can see here's Python, and it's slowly getting more and more used up, right? So now we're almost at a gig of RAM. And it's basically going to go keep taking that memory until either the script finishes or your computer runs out of RAM. And if that happens, then the script will actually give you an error. So you want to, as you try to process more and more data, you want to keep an eye on this. Okay, and there's obviously, you know, if you don't have enough RAM, you can always use a machine with more RAM. There's a limit to that, right? If I had 16 gigs, which is quite a lot of RAM, all I can do is twice as much processing. Okay, so there's always going to be a limit to how much you can do with your own kind of personal machine. If you ever have a situation where you need to process more data than you have available, there's other cloud-based and kind of larger infrastructure solutions for that. Okay, but for the purposes of this kind of demo, I'll be okay just controlling the amount of data so it can run on my local machine. Alright, so now that's finished, you can see that I stayed within my limits of RAM, so it was okay. Here it's finished. It's told me that about a quarter of the words were specific to OCT and about 3/4 were not. And in my file browser, I've generated all this data, the text files of the words, also the list of words in pickle format, and the list of training strings.